Thank you, Mr. Andy. As we have seen, simple solutions such as a mask and social distancing has significantly reduced the infection of this pandemic. We at SoftSquare have solutions based on QR code, GPS, Wi-Fi, Bluetooth, and Einstein AI Vision for the COVID-19 reopening initiative, mainly automating health screening, shift scheduling, and contact tracing. Last week, we looked at how Einstein Vision can be used in the following applications for marketing, field services, financial services, retail execution, and consumer goods cloud. Today, our lead Einstein AI Solutions Architect is going to demonstrate how Einstein Vision is used in Salesforce Work.com to detect masks in real time for public health safety. Here is the SoftSquare AI platform. The high-level pipeline starts with object detection to identify faces in a video using a deep learning method called CNN, Convolutional Neural Network. Then, Einstein Vision classifies the faces with and without mask. This information is then sent to work.com. And from there, it gets fed into Einstein Analytics for quantitative and qualitative analysis for visualization, planning, monitoring, and alerting. Also, in the upcoming webinars, we will be presenting social distancing, group and social gathering detection using Einstein Vision. Now to our lead Einstein AI Solutions Architect, Raj Kumar.
Hello everyone. When we started thinking about creating a mask detection system for office reopening, we wanted to utilize the Salesforce Einstein AI capabilities to full extent. And we want to use other AI technologies wherever necessary. Salesforce Einstein AI's Vision application is capable of identifying objects if it is trained to do that. So we have trained our Salesforce Einstein AI's Vision application to identify and distinguish people wearing masks and not wearing masks. This we have done by uploading thousands of random people images with masks and without mask. Also, we want to use Salesforce Einstein Analytics capabilities. So we passed all these mask identification data to Salesforce Einstein Analytics to discover insights, predict outcomes, and find recommendations so the customer can act quickly according to the outcome of Einstein Analytics for their company policies. The whole plan is to input live camera footage from office entrance. Identifying and cropping individual faces from the live footage is not available in Salesforce AI system, as it is not their core area of interest as a CRM. So we have decided to use cutting-edge open source technologies to do that work. Host those images in Salesforce Heroku. From there, Salesforce Einstein will pick the images and continue the identification process. Now, our Salesforce Einstein Analytics Senior Engineer, Kanmani, will show you how the vision data is stored in work.com and analyzed using Salesforce Einstein Analytics.
Now let's look at the Einstein image classification algorithm. We have built a model to detect mask or no mask. We have uploaded the image. As you can see the result here, which is 100% accurate. Now let's look at the result from the camera feed. We can see the status and the prediction accuracy here. Finally, let's look at the work.com command center. Here you can see health screening, contact tracing, and shift scheduling metrics. In the command center, we have also embedded the Einstein Analytics dashboard. On the key metrics, we can see the maximum occupancy for the location from the shift schedule model integrated with Einstein Vision to detect the number of employees in that location with and without mask. Here we can see mask detection statistics over time, and on the right side this chart shows the vulnerability level of employees without masks. And if I scroll a little bit down, here an alert triggered if the mask violation is detected. So we have done with the demo. Hopefully all of you understand the process. Thank you so much.
Okay, great. Thank you, Kanmani. So now what we're going to do is go through a live demo, and also we'll actually show you a live application that you can run on your computer to do the detection. So we're going to go ahead and take a look at the this particular screen, and then I'm going to go ahead and put the URL on the chat box. So let's go ahead and do that first, and then after that we'll open up for questions. So what we would like to do first is go through the, let me go ahead and share the screen so you can see live the application. Share, okay, there we go. So on the left side is a YouTube video. So we picked up 3 videos, and also we took some footage locally and we tested that as well. But in this case, we have 3 footages that we are going to use for this demonstration. One is from a camera feed, so it's very fuzzy and the angles are off. Another one is from a classroom, and another one is from an office space. So we have 3 different videos that we're going to feed into the AI system, and we're going to detect the faces first, and then we're going to start detecting the mask. So we're going to go through that whole process. So let me go ahead and play the first video on the left side. So when we look at the first video on the left, that's the footage. It's about 6 seconds long. And so you saw that this particular footage has a scene here where you have 3 folks with the face mask, 3 employees with the face mask, and then the next one, there are 4 employees without the face mask. Now we're going to go ahead and start looking at this footage and see how the Einstein AI processes this footage. Now first, the soft squares image extraction component is going to run. So it's going to extract the different frames from the video. And then once it extracts the different frames, as you can see, it's going to find the duplicates, it's going to drop the duplicates, and it's going to crop just the face. So let's go ahead and take a look at that. Now this application is not just for face mask detection. It could be used for detecting different ads or different artifacts in your company. It's not just for face detection. So let's just go ahead and look at it here. So let's say I do the select. The Einstein engine is running on the right side. This is the soft square component that's doing the object detection. It picks up the different faces from the video. And as you can see, once it's done with that process, it's sent to Einstein, where it's going through and detecting which faces have the mask and which faces don't have the mask. And as you can see, there are a few, it's kind of a true negative, because if you look at it, the different angles of the face shows up as the same person. And those can be cleaned up and optimized further using more training data. So that's what the first video did. And then once that's done, the data is passed into Einstein Analytics, and the metrics is displayed on the command center dashboard. As you can see, entry without mask, and it shows you an action. Now, let's go ahead and take a look at another video. Now, this is the school setting where we have 2 sets. Here, everyone has a mask. And the second set, everyone does not have a mask. So it's going to go through this footage, and it's going to extract out the students with the mask and the students without the mask. So let's go ahead and take a look at this. Again, the soft square OpenCV AI system is extracting the images from the video clip. And it's in my cache, so I had to clear my cache, sorry. All right, let's run this again. Play and select. Again, this is running on a Google GPU compute. This portion where it loads the video file, extracts the different images, and processes those. As you can see, the first step is the soft square component goes in and picks up the faces and then sends it to Einstein. Einstein here detects the faces with the mask and without the mask. So we have trained the Einstein AI Vision system with masks and no masks, so it goes in and separates the 2. And then once that's done, it's sent to work.com and populated in this dashboard. And this is a custom object for just mask detection. And we're using the work.com health screening, shift scheduling, and contact tracing. We're using all those three components together to bring up this holistic dashboard. So I can go ahead and pass this URL. So we are going to allow the, you can upload your own video, an MP4 or MOV or AVI. You can upload those videos, and the system is going to send it to Google Compute and process each frame, extract out the duplicates, and then crop out the face and help you detect if that particular video has a mask or not. So this is one way to do it. Now, we have not yet opened the Google Compute just because there's a cost for processing each one of these footages, but we will be opening it up on a case-by-case basis. So if you want access to it, please let us know, and then we'll go ahead and give you a license to access the that component. Let me go ahead and put the, actually, can you post the URL on the chat, please? So now
I just posted the URL, Mr. Alex.
Thank you. So thank you, Purnima. So she is our campaign manager, and she's been the one sending posts on these webinars. And she's going to reach out to you after this webinar to see if you need access to this type of processing. Now, at this time, we have trained the Einstein AI model just for masks and no masks, but it could be used for other areas as well. So let's go ahead and take a closer look at what's happening, and let's also take a look at some of the false positives that you may run into. So let's take a look at an actual footage here. So I'm going to go ahead and play this. This is an actual footage from the street. Now, as you can see, there are two folks here with the mask and two folks without the mask. So what this algorithm does is detects the faces first, and then looks at the faces to see if they're duplicates or not, and then it searches to see if there is a mask. So it kind of does three different steps. So let's go ahead and run this specific example. So let's go into the process another video. And then let's go ahead, and this is the Heroku app where the AI application is running for SoftSquare. So let's go ahead and run the last one. Again, the video is being uploaded, video is being processed, the images are being extracted, and all the faces have been identified. As you can see, they're really blurry. And once the faces have been cropped out, it's sent to Einstein, where it goes through its convolutional neural network, and then it kind of separates out which faces have masks and which don't have masks. And then as soon as that step is done, the data now is from image. It moves to more qualitative and quantitative data that goes into your work.com component. So this is the workflow end-to-end in a nutshell for the face mask detection. Next week, we're going to look at social distancing. So we're going to go ahead and have a bounding box around each person in the frame and see how close they are, how closely they're walking together. And let's say if we find someone walking together closely for a certain period of time, we're going to assume that they're from the same group, and we may ignore that, and then we would be looking for ones where the bounding boxes are far apart. So there are different algorithms to do social distancing detection using computer vision. We already have a contact tracing solution using the Bluetooth BLE sensor, where if your phone has the Bluetooth enabled and the SoftSquare contact tracking application, if two phones come close together, it's going to detect the proximity, and that's more accurate than the Einstein Vision, but it can be used in combination. So that's the contact tracking bot webinar that was there. I think 2 weeks back, there was a webinar on that particular process. And maybe Purnima, if you can send the attendants the link to the contact tracking as well as the mask detection, that would be good.